Hello students, welcome to Shikuya Let's Upskill. Welcome you all in this another live session of TCS NQT preparation. I hope you all have registered for the TCS NQT for all the 2023 passing out students, and you will be also started, you might have also started your preparations in order to crack this NQT. So Shikuya is all set to help you all students in order to prepare for all the sections of TCS NQT. So here we have came up today with the one of the live session on quantitative aptitude, and the topic that I'm going to cover today, I'm going to cover the frequently asked questions from TCS numerical ability from the topic of time, rate and work. So as you know, TCS has the two sections this time, that is, first is the foundational and the another one is advanced section. In both of the sections you have to face the problem of numerical ability. So numerical ability is nothing but the quantitative aptitude. So time, rate, work is considered to be one of the very important chapter of this entire quantitative aptitude or the numerical ability. So we are going to understand today how to solve the problems of time, rate, work. There are multiple methods. The first method is called the unitary method. Okay, first is unitary method, in which entire work done is considered to be 1, and on that basis all the calculations are carried away. The second method is called the LCM method, where the total work done is considered to be the LCM of the given time units. So straight away, unitary method is very complicated or difficult when it comes to the multiple people involved in doing multiple work. So straight away I will be explaining you about the LCM method, which is very simpler to solve, and you can solve the problems of time, rate, work within a couple of seconds by using the method LCM. So let us start solving the problems with this LCM method itself. Okay, so let's go to problem and just take an example of time, rate, work, and just understand how the LCM method works. The first problem is there in front of you. So A can finish a piece of work in 12 days while B can do it in 15 days. If both work at it together, what time will they take to do the work? So very simple table you all have to draw, and that is how you can solve the example of such type. So just look at the table how I am going to draw it, and that is the same way you have to organize the data into the table. So here it is time, here it is rate, and here it is work. Okay, so there are two people involved in this example. So the first is A and the second one is B. So I'll write the time of A. A can finish a piece of work in 12 days. So I'll write the time of A over here. Next is, while B can do it in the 15 days. So I'll write the time of B taken to finish that work is 15 days, which is written over here. Now in the LCM method, what I have to do is I have to assume the work done by both of these people. So I have to assume a common number which could be divisible by their respective time in order to calculate the rate. So I'll assume the work done to be the LCM of these two numbers. So what is the LCM of 12 and 15? The LCM is 60. Now how to find out the LCM of any given numbers? Quickly just find out the largest number out of the set of the given numbers. Find out the closest multiple of all the remaining smallest numbers given the series. So 60 is the LCM of both of these. So now I have the time of both of them, I have work done of both of them. Now I have to calculate the rate. So simple formula of time, rate, work is T into R is equal to W. Now in order to calculate R, what I have to do? R is equal to W upon T, right? So here, by simply applying the same rule, 60 upon 12, the rate will be 5. 60 upon 15, the rate will be 4, right? Now I have to calculate A plus B together, how much time they have took. So work done, I'll again assume 60, same for A and B together as well. Now Now the rate will be combined because A and B both have combinedly worked. So the rate with which A works is 5, the rate with which B works is 4. So when they both of them together working, their rate will be added together, right? So here now I have rate, I have work done. So how can I calculate the time? So time is equal to work upon rate. So here 60 divided by 9. Your answer will be 6 integer 6 by 9, that is 2 by. So here it is 6 integer. So how much time A and B will together take to finish this unit of work is 6 integer 2 by 3, which is given in the option A is 6, B is 8 days, and option C is 6 integer 2 by 3. I hope you all have understood. So this is a very simple method in which you have to just assume the work done to be the LCM of both of the given work dones, and accordingly you will be able to solve it further. Let's go to the next problem. So students, while you are solving the examples from the quantitative aptitude, it is very important to save a lot of time while you are solving the examples. The reason behind this is you have a very calculated time in order to solve the multiple examples. So your approach has to be only and only how much you can solve the maximum of time while solving the simpler examples. Let us go to the second example, which is there in front of you. Just look at this and try to solve with the same method. So here again I will have to draw the same table: time, rate, work. A can do a piece of work in 10 days. So again here it is A, then B and C. So here 3 people are involved. In the last examples there were 2 people, only A and B. In this example there are 3 people. So A can do a piece of work in 10 days, right? B can do a piece of work in 12 days. C can do the piece of work in 15 days. So I have to draw the same table. Okay, in how many days they can complete the work working together? So I have to again assume the LCM to be 60, 60, 60, right? So just calculate the rate over here, which is 6, rate over here, which is 5, here it is 4. Now further, what they have asked, in how many days they can complete the work working together. So what is the together rate? 6 plus together LCM, that is work done has to be done same, that is 60. 6 plus 4, 10, plus 5, 15. So together how much time they will require is 60 upon 15, which is equal to 4 days. So that is as simple as that. The only thing which you have to do very carefully over here is to form this table. Once you are able to form this table very much accurately, very much precisely, you are all set to solve the examples of time, rate, work. So let's go ahead with the next example. Next example, A can do a piece of work in 5 days. So same table. B can do it in 10 days. Okay. C and A plus B plus C together. So here A can do it in 5 days. B can do it in 10 days. C they haven't mentioned, and with the help of C, they finish the work in 2 days. Means when A, B and C, these 3 people together are working, they can complete the work in just 2 days. So what the question is, in how many days C alone can do the whole work? So again, just try to assume the LCM of these three numbers to be the work done. So 5, 10, 2. So LCM is 10, 10, 10 and 10 everywhere, right? So first the rate is 2, second the rate is 1, third we don't have the time which has been taken by C, but we have the time taken by A plus B plus C together. So here the rate is again 5, right? So the combined rate of A plus B plus C will be the addition of rate of A, B and C. So here the rate of A and B is 3, rate of A and B and C is 5. So 5 minus 3 will be the rate of equal to 2, right? So now I have a rate with which C is working, that is 2. So I have to just calculate the time of C, which comes to be 10 upon 2, which is 5 days. My answer would be 5 days, which is given in the option, I guess, option C. So here is the answer. So again, only there will be a different combinations, different twisting or different deviations in the problem which will be asked over there. But if you are successful in building this particular table, you will be all set to solve the examples of time rate work. Next, let's go to the next example. Okay, the next example is A can do a piece of work in 24 days if B is 60% more efficient than A, then the number of days required by B to do the same piece of work. It is a simple example of application, I could say, of ratio and proportion. So how can I solve that? Just look at the way. A can do a piece of work in 24 days. So A can do it in 24 days. Now what they have given, B is 60% more efficient than A. So when I have to write the ratio of efficiency of A is to B, so efficiency is nothing but the rate at which they work. Okay, so I have to just write the efficiency of B is to A. So B's efficiency is 60% higher than that of A. So suppose if A completes 100 unit of work in a unit time, then in the same time B completes 160 unit of work. That is what the ratio of their efficiency. So if I solve it further, it is nothing but 8 is to 5. That is 8 upon 5 is the ratio of efficiency of B is to A. Now the ratio of number of days taken by them is inversely proportional to the ratio of efficiency. So the number of days ratio, if the efficiency ratio is 8:5 of B is to A, then the ratio of A upon B of number of days taken will be 8 upon 5. So here number of days taken by A are 24 and we have to find out the number of days taken by B. So just you have to do the cross multiplication, right? So which is nothing but 24 into 5 upon 8, which comes to be 15. So your answer is 15, which is given in the option B. Once again, I would like to just quickly explain. They have given the efficiency of B, which is greater than 60%. So I have just written down the ratio of rate of B is to A, which is 160 upon 100. So when I have converted it to the ratio, that is 8/5, but the ratio of number of days taken will be inversely proportional to the ratio of rate or the ratio of efficiency. So the ratio, as the ratio of B upon A is 8 upon 5, that is the ratio of efficiency, the ratio of days taken of A upon B will be 8/5. So the number of days taken by A have been already given. I have to just calculate the number of days taken by B. The answer is 15 itself. So I hope you all have understood. Let's go ahead. Next problem. Problem number 5. Okay, so here is a little bit again twist is that there in the problem. Raja can do a piece of work in 14 days. Okay, again time, rate, work. Here is two characters, Raja and Rani, right? So Raja can do a piece of work in 14 days. Rani can do the same work in 21 days. Okay. Now you have to again assume the LCM to be the work done of both of them. So I will assume the LCM to be the 42. Okay. So 14 3s are 42, 21 2s are 42. So their combined rate will be 5. Okay. Now just read the statement further. They started the work together, but 3 days before the completion of the work, Raja left the work. The total number of days to complete the work is. Now you have to just understand the total work done is of 42 units. Total work done is of 42 units. Now in the last 3 days, Raja has left the work. So in the last 3 days, Rani alone has completed this particular work. So what is the rate of Rani? The rate of Rani is 2. So with the rate of 2 for last 3 days she has worked alone. So for how many units of work she has completed while working alone? That is 3 into 2, which is the 6 units. Now total work done to be done by both of them is 42 units. So 42 divided by 42 minus 6, which comes to be 30. Now this 36 units of work has been completed by both of them, that is Raja and Rani, and with the rate of 5. So now how many days they might have took to complete this 36 units of work divided by 5. How much it is? It is 7.2. Okay. So together how many days they have took? 7.2 days together and 3 days while Rani has worked alone. So how many days? It is 10.2. So 2 is nothing but 1 by 5. So the answer is given in option D, which is 10 integer 1 by 5. So it is as simple as that. Just listen carefully once again. I'll explain once again. Here they have given the both two characters, Raja and Rani. Okay, they while working together their combined rate is 5. While working individually, the Raja has a rate of 3 units, Rani has a rate of 2 units. Now before completion of the work, 3 days prior, Raja has left the work. So it means Rani alone has worked for the last 3 days. So out of the 42 units, how many units she has completed in those last 3 days? It is 2 into 3, which is equal to 6. So let us subtract the 6 units of work from the entire number of units, that is 42. So 42 minus 6 remaining is 36, and that is being completed by both of them, Raja and Rani. So Raja and Rani completes that particular work with the rate of 5. So 36 divided by 5, answer is 7.2. Total number of days taken by both of them is 7.2 plus 3, which is equal to 10.2, which is nothing but the 10 integer 1 by 5. That is your answer, which is given in option D. Okay, so hope you have understood. Students, I would also like to tell you, if you want to learn such more fantastic tricks, if you want to practice more and more such problems which will help you crack your TCS NQT for this season and grab the wonderful job opportunity, I have something very interesting for you to show. So just look at the desktop application which we have offered over here, and where you can prepare such problems, such tricks, techniques from our course of TCS NQT. So here is the just course window in front of all of you guys. So what we have done is we have segregated the sections as per the sections which will be asked in the TCS. So we have verbal ability, quantitative aptitude, logical reasoning as well. So if you click in the quantitative aptitude, we have segregated the number of chapters in different sections. So here is the basic aptitude, business aptitude, combinatorics, geometry and mensuration, number system, relative speed. If you click on the basic aptitude, you'll find the different chapters in the section. Okay, so accordingly you will be able to find the segregation of each and every chapter. Again, if you go to the next, that is logical reasoning, again there will be a different section in the logical reasoning. You will be able to solve, practice problems according to that section, according to that chapter, and also the most important thing in the application which you may avail and you may take a great help of the same is you can solve the practice problems according to the chapter and according to the section as well. Then as soon as you finish a particular number chapter, as soon as you finish a particular number of examples, you will be also able to solve the multiple mock tests which will be available in the course itself. As soon as you go on preparing for this TCS NQT, as soon as you complete the preparation level 2, 3, because TCS has given an opportunity to select for the TCS Ninja as well as digital, both the profiles. So you can also get selected for the digital profiles as well by preparing well and by cracking the advanced level aptitude questions from the same test. So for that, the practice is very, very essential, very, very important. So in order to achieve to that great extent, you have to solve the multiple mock tests as well. So here in the assessments, we will be able to map the mock test for you all guys. As soon as the TCS comes, as soon as it arrives on your doorsteps, we will be able to conduct your TCS specific mock tests where you will be able to understand where are you lagging, in which chapter you have to do more practice, in which section you are lagging, in which part of verbal ability you have to solve more practice problems. These all the statistics, these all the data will be there in front of you, and that is where you will be able to prepare more and more, and you will be able to grab the opportunity into the TCS. So that is how we are all set to help you in your preparation of TCS NQT. I urge you, I request you all to just visit our website www.shikuya.com, download the desktop application and just take a free trial of the course TCS NQT. You will be able to realize the value which we people are offering. Okay, just go ahead to solve the further couple of examples. Next example is okay, problem number 6 we are going to solve. The number of days required by A, B, C to work individually is 6, 12, 8 respectively. Again, we have to draw the same table over here, time, rate, work. Okay, I'll write over here A, B and C. Okay, the number of days required by A, B, C to work individually is 6, 12 and 8. So 6, 12 and 8. Okay, they started work doing alternatively. If A has started and they followed by B. So what I have to do is I have to just calculate their individual rates. So what is the LCM of these three numbers? The LCM is 24. Okay, so here the rate is 4, here it is 2 and here it is 3. So what they have given further, they have started working alternatively. Alternatively means A has worked for 1 day, then A left, then again B worked for 1 day, B left, C worked for 1 day, C left. So likewise, the total units of work to be done, to be completed is 24 units, out of which when A works for a day, he completes 4 units of work. When B completes 1 day, he completes 2 units of work, and when C completes, he completes 3 units of work. So after completion of 3rd day, the number of units that has been completed is 6 plus 3, that is 9. Right? So after one iteration of all of these 3 people, 9 units of the work has been completed. So to complete the 24 units, how many such iterations are required? Just calculate. 9 2s are 18. So after completion of 2 iterations, that is 6 days, how much work done is remaining? Remaining work done is 24 minus 18, which is 6. Now after these 2 iterations, again A will work, so A will complete 4 units of work, and then after that B will complete 2 units of work. So this 6 units of work will be completed in the remaining 2 days. So how many days are required? So in the first iteration 3 days, in the second iteration 3 days, and in the third half iteration 2 days. So how much total? Is 3 plus 3 6 plus 2 8 days. 8 days are required to finish the work when they work alternatively. So answer for this question is given in the option A, that is 8. I hope you all have understood. Okay, let's go to the next example again. So the next example is the multiple people involved in the work. So here in the problem, what they have given is 12 women, okay, can do a piece of work in 20 days. So 12 women, 20 days, okay. And what they have asked is, if the 4 women deny to work, then how many more days are required? So straight away, the number of men into number of days they have worked is the total volume of the work. So here what happens? 12 women do a work in 20 days. Here 4 denies to work, means how many women have done it? 8 women. So number of days required. So 12 into 20 upon 8, which is equal to number of days. So what's your answer? 240 upon 8 is equal to 30. So the question is, how many more days are required? Earlier the number of days required were 20, now it is 30. So 10 more days are required. Option answer is given in the option B. I hope you all have understood. Next, problem number 8 is also same type of problem. Okay. 35 boys can do a piece of work in 15 days. Okay. And then work was completed in 25 days. The work was completed in 25 days. How many boys did not turn up for the job? Now here it is 25. So how many boys were working? So just you have to cross multiply this on 25. So how many boys? Okay, 5 sevens are, 5 fives are, 5 threes are. Okay, 7 threes are 21. So here when it took 25 days to complete the work, number of boys employed were how many? 21. So just calculate 35 minus 21, which is equal to 9 plus 5 equal to 14. So the answer is 14 boys did not turn up, which is given in the option A. Okay, so hope you have understood. Go to the next problem. Now these all the problems are very simple. They will be asked in the foundational sections of the numerical ability of TCS. You have to just check out the right method which will take you to the precise answer. Problem number 9, 24 men can complete a job in 40 days. Okay, the number of men required to complete the job in 32 days into number of men. So again 24 into 40 divided by 82, 8 3s are, 8 4s are, 10s are. Answer is number of men required are 30, which is given in the option. So I hope you all have understood this wonderful techniques to solve the problems of time rate work, which is a very important section of the numerical ability of TCS NQT. Such type of problems will be asked in the foundational sections of TCS NQT. I hope you all have understood all the questions which I have covered over here. In order to solve such more number of examples, in order to understand such more tricks, techniques, I wish you all the best to prepare the best for the upcoming TCS NQT. I urge you all to subscribe to our YouTube channel, hit the bell icon so that you will be notified about all these live sessions we will be conducting and help you all guys to prepare for the TCS NQT. Don't forget to go to visit our website and download the desktop application and take a free trial. Thank you so much. Bye bye. Have a great day ahead.